Oh, good morning. Today I'll be teaching you how to solve question 25 from Energizing Physics lesson 3.9. So in this problem, you're given that a box is resting on an inclined plane and somebody is pulling on it. And so you're trying to find, in this problem, the minimum and maximum pulling force so that the box stays at rest. And so you're given that the coefficient of friction between the box and ramp is 0.4. Well, the static friction is. The reason why I use the static and not the kinetic is because if the box is staying at rest, then static friction is acting on it. You're given that the force of gravity acting on the box is equal to 130 newtons, and that since this is on an inclined plane, it can be split up into an x and y component, with the x component having a force of 50 newtons, and the y component having a force of 120 newtons. And like I said before, you're trying to find the F pull minimum and maximum. And so the important concepts to remember when solving this is that F friction is equal to the coefficient of friction times the normal force, and that in this case F net is equal to F pull minus F friction minus F gravity, or F net is equal to F pull plus F friction minus F gravity. And the reason why I can set it up like this is because for the minimum maximum cases, there are two cases where you're pulling enough, the force of your pull is higher than the force of gravity, such that the force of friction starts going against it in order to keep it at rest, or which gets you the maximum, or the force of gravity is greater than the force of the pull, such that the force of friction has to keep it up. And so, when solving this, we first should solve for force of friction. Since the box doesn't move up or down against the ramp, we know that the normal force, must be equal to the y component of the force of gravity, or 120 newtons. And so, F friction will be 0.4 times 120, or 48 newtons. Since the box is staying at rest, that means that the net force must be 0, or else work would end up happening. And so 0 equals F pull minus, filling the variables, 48 minus 50, or 0 equals F pull plus 48 minus 50. So solving for F pull, we get that F pull minus 98 is equal to 0, or 0 is equal to F pull minus 2. So thus getting F pull is equal to 98 newtons, or at the maximum, or at the minimum, F pull is equal to 2 newtons.
Did you pause it yet?